Hello everyone, welcome to lecture number 5. In this lecture, we will see how to write a MATLAB code to determine bus admittance matrix, that is Y bus matrix. So before this, we will see some basic definition. First is element node incidence matrix, that is A augmented matrix. The element node incidence matrix has dimension E cross N, where E and N are number of elements and node respectively. Second is bus incidence matrix, that is A matrix. The bus incidence matrix has dimension E cross n minus 1. Since one node becomes reference because we are removing the column corresponding to reference node, and we will use this matrix A matrix for calculation of Y bus. So let us take one example, and with the help of this example, first we will calculate Y bus matrix manually, and then we will verify the result with the help of MATLAB code. So we have this network. So this network has 5 nodes, or you can say 5 buses, and 6 elements. So first we will draw the oriented graph of this network, and from that we will calculate A and A augmented matrix. The impedances of the element is given for the calculation of primitive impedance and primitive admittance matrix, that is Z and Y matrix. So this is the oriented graph of the network. So I have assumed bus 1 as a reference bus, and we have 5 nodes, that is 1, 2, 3, 4 and 5, and number of elements are 6. So here nodes equals to 5, number of elements are 6, branches are 4 and links are 2. So next we will calculate A augmented. So this is 1. So we have reference node 1, and element number 1 is connected between 1 and 2. So the element number 1, it is away from this node, so it is 1, and it is coming towards this node, so it will be a minus 1. So here you will get the answer. Similarly, you can calculate for other nodes and element. So now I will remove this column corresponding to reference node, and then I will get bus incidence matrix, that is A matrix, and this matrix we will use for the calculation of Y bus. So the impedances of the elements are given. So from that I have calculated primitive impedance matrix. So we have 6 elements, so the dimension of matrix will be 6 cross 6. So similarly we'll get primitive admittance matrix. So simply make the inverse of this, you will get primitive admittance matrix. Next, bus admittance matrix. So Y bus equals to A transpose Y into A. So we have A matrix, make the transpose of this. Then you have Y matrix and A matrix. So simple multiplication is there. So Y bus equals to A transpose Y into A. So you will get this result by manually. Now we will see how we will get the answer with the help of MATLAB code. So this is the MATLAB code to determine the Y bus. So I will specify here n equal to total number of nodes, equals to total number of elements. So b is equals to n minus 1, l equals to, so there is a no requirement of this. So what we will write here, so a equals to zeros e comma n. So it will create the matrix of zeros of dimension e cross n. So we will use for loop here for I equals to 1 to e, that is I equals to 1 to number of elements we have 6. So I will initialize first s of I equals to input, enter the element to be added, p equals to enter the starting node, and p equals to enter the ending node. So if p is not equals to 0, a of ip equals to 1, that is suppose element 1 I have to add and the starting node is 1, so we will get the answer 1. We already seen this in the PPT. Similarly, for suppose element number 1 is added and ending node is 2, you will get minus 1. So end the both the statement by writing end. So a cap equals to a. So this matrix we will get here. So a1 equals to a cap. So we will get burst incidence matrix. So this notation will shift column from 2 to n equals to 5. So it will remove the first column corresponding to reference node. So similarly end the first loop. Next we have y and z. So next loop here for z equals to 1 to e, z of jj, enter the value of impedance. So it will take the value of impedance. Similarly end this, then y equal to inverse of this z. Then we have a1 that is burst incidence matrix, a1 transpose y into a1. You will get burst admittance matrix here. So another MATLAB code we have. So similarly we will specify here n and e. So here I will not enter the element to be added. I will directly take the starting node, ending node, and impedance in a matrix form. So program is same. So I will run this program and we'll verify the result. So it is asking me for number of nodes. So we have 5 nodes and number of elements are 6. So enter the starting node, ending node, and impedance in a matrix form. So we have first starting node 1, ending node 2, and impedance is 0.1. So close the bracket. Next we have 2, 3, and 0.1. Next we have 3, 4, 0.2. Next we have 2, 4, and 0.2. Next we have 4, 5, and 0.25. And last is 1, 5, and 0.25. So it will, I have added the element serially, that is 1, 2, 3, 4, 5. Okay, so it will take serially from 1 to 2, it will take first element and the impedance of that element. So I'll enter this. So we'll get the same result that we have calculated manually. And similarly we got the Z bus. This is Y bus, we got Y bus by singular transformation. And this is the value of A matrix, that is bus incidence matrix, and the value of A augmented. So in this way we can easily calculate the value of bus admittance matrix using MATLAB code. So thanks for watching the video.